Kimberto presents, as part of a project for College of Marin, Geology 249, the Purisima Formation. The Purisima Formation, located in Central California, is a geological formation. A geological formation is a rock unit having a consistent set of physical characteristics which distinguish it from adjacent bodies of rock. It also occupies a particular position in the rock layers. A formation must be large enough to be shown on geologic maps. Looking at this map, the darker areas represent outcrops of the formation. These discontinuous outcrops are located in Marin County at Point Reyes at the top of the map, which is in the north, then south of that in San Mateo County, and even further south in Santa Cruz County. This formation is made up of sedimentary rocks, mostly sandstone and siltstone, which were deposited in a marine environment from about 7 million years ago to 2.5 million years ago. The Purisima Formation is characterized by occupying the same stratigraphic positions across the different sections, and it consists mainly of fine to coarse-grained clastic rocks, mostly sandstone and siltstones, with dark andesitic fragments. It has locally abundant silicic tephra. Volcanic ash would be an example of that. It has scattered outcrops which have been displaced by strike-slip tectonics. Looking at this map, the Purisima Formation can be divided into 3 geographic sections. Starting from the south is the Santa Cruz section. Then the San Mateo section is to the immediate north, and the Point Reyes section is much further to the north. Here's a view looking southward along the San Mateo County coastline. Notice the typical steep, jagged cliffs, the headlands, and the marine terraces of the Central California coast. This map depicts the Central California coast during the early Pliocene, about 5 million years ago. Notice the location of Monterey, California, as indicated by the top arrow. It is about 40 kilometers off the Pliocene coast, out in the water. The current California coast is shown by the dotted line. The red arrow shows where the Purisima Formation was deposited underwater on the continental shelf. These deposits were inner, middle, and outer shelf deposits. Marine sediments are deposits of insoluble particles that have accumulated on the seafloor. These deposits can be from biogenic, volcanic, or cosmogenic sources. However, they are primarily rock and soil particles transported by rivers, wind, or glaciers to the sea. Over time, buried sediments which are compacted and cemented can become sedimentary rocks. Ocean sediments from rivers form in a fairly predictable sequence from the coastline out into the deeper ocean. Generally, larger sediments fall out of the water first. Looking at this diagram, the larger sand particles deposit in the near shore area, later becoming sandstone. Silts deposit next, a little further out on the continental shelf, then clays. These both can become shale. In warmer water, coral can later become limestone. Rocks and fossils of the Purisima Formation contain information about past climates, sea level changes, tectonics, sea temperatures, and much more. This diagram highlights some of the general features of the 3 sections of the Purisima Formation over time. The far left is a timeline with younger layers near the top of the diagram at about 2.5 million years ago. The bottom is about 10 million years ago. The far right shows relative sea level change over time. There's a lot of information on this diagram which we will not delve into. However, it does show us how much variation there is in the Purisima Formation from section to section. For example, the San Mateo coast section, see where the red arrow is, has 5 discernible members to it. However, these are not detectable in the other 2 sections. Also notice the Santa Cruz Mudstone and the Santa Margarita Sandstone are 2 other formations which the Purisima Formation overlies. Here again is a current map of the Purisima Formation along the central California coast. The red stars indicate outcrops I have visited along the coast. On the top left of this map is the northernmost outcrop of the Purisima at Point Reyes in Marin County. Headed south, the next two stars indicate outcrops on the San Mateo coast. And finally, the bottom two red stars, furthest south, indicate locations in Santa Cruz and Capitola, both within Santa Cruz County. Let's have a look at these locations. These are the cliffs at Drake's Bay containing an exposure of the Purisima Formation. The formation here is composed of diatomaceous siltstones and fine sandstones with thin inner beds of mudstone. Invertebrate fossils occur here less than at other locations of the Purisima Formation further south. Just how did the Purisima Formation end up so far north of its place of deposition? Well, the San Andreas Fault moved it northward. Note the red arrows indicated by the number 1 on this map. These arrows show the relative directions of the land on the west versus the east side of the San Andreas Fault. The western side of the San Andreas Fault is moving northward faster than the eastern side is by about 1 or 2 inches a year. The result is that this portion of the Purisima Formation, which is on the western side of the San Andreas Fault, has been moved northward about 160 kilometers since the late Miocene, as indicated by the yellow arrow. This geologic map shows the geological formations and deposits of the Point Reyes National Seashore. These formations and deposits are color-coded. The red arrows highlight the locations of the Purisima Formation, indicated by TP, and its closely associated formations, the Santa Cruz Mudstone, TSC, and the Santa Margarita Sandstone, TSM. The relative movement of the western portion of the San Andreas Fault moved these parts of these formations together from the south. Here is a view, looking northward, of the cliffs along Drake's Bay containing the Purisima Formation. For a brief time, this was considered part of the Drake's Bay Formation until about 1984, when it was recognized as a northern section of the Purisima Formation. Note the wave-cut benches in the foreground. If you are interested in these and similar coastal landforms, please watch my other presentation, Coastal Landforms of Santa Cruz, California. About 50 miles south of Point Reyes on the San Mateo coast, our next stop is at the Fitzgerald Marine Reserve in Moss Beach, California. The Purisima Formation is exposed here as a plunging syncline. A syncline is a fold in the rock layers that occurs as a result of compressional forces. This outcrop is also fairly fossiliferous. Not only is the geology interesting here, but this location is renowned for its tide pools. About 15 miles further south towards Santa Cruz is San Gregorio State Beach and another outcrop of the Purisima Formation here on the San Mateo coast. This outcrop contains fine-grained sandstone, silty mudstone, and a whiter layer which contains a lot of volcanic ash. This is an example of the locally abundant silicic tephra we mentioned earlier. Here is another view of the Purisima Formation at San Gregorio State Beach. This is known as the Tahana member of the San Mateo coast section. Looking at the ash layer, notice how irregular and convoluted the bottom boundary of this white layer is. This is likely due to what's known as soft sediment deformation, which means when the whiter ash sediment was deposited, it sank into the soupy, soft underlying layer, resulting in this uneven border. A little further down the beach at San Gregorio State Park was an outcrop of a more fossiliferous portion of the formation. The fossils here appear to be mostly disarticulated bivalves. A few miles southward, in the city of Santa Cruz, this is another outcrop of the Purisima Formation, which is on the beach at the end of Swift Street. Notice the bottom layer is part of the Santa Cruz Mudstone, the formation directly below the Purisima Formation. The Santa Cruz Mudstone was deposited from about 9 million years ago to 7 million years ago. So this section here, including the Santa Cruz Mudstone, the Purisima Formation, and the more recent beach deposit, represents about 9 million years of deposition. Here is another view of the Swift Street outcrop with the wave-cut platform of the Santa Cruz Mudstone and the Purisima Formation in the cliff. A visit to this outcrop would not be complete without discussing the methane seeps which are found here. These bulbous light-colored features shown on the Santa Cruz Mudstone here are remnants of methane seeps, also known as cold seeps. These formed when the Santa Cruz Mudstone was still mud in deep water 7 to 9 million years ago. This diagram shows how these methane seeps were formed. Decaying marine organisms in the source sandstones on the bottom of this diagram gave off gases such as methane and fluids which worked their way to the top through the conduits in the Santa Cruz Mudstone and were then released into the ocean. The carbonate minerals they left behind formed the bulbous light-colored structures we see today. After leaving Santa Cruz, we head about 6 miles east. Remember, we are on the northern east-west portion of Monterey Bay, to Capitola. The Capitola outcrop of the Purisima Formation is well exposed and relatively easy to access, at least at low tide, and is very fossiliferous. The beach here is beautiful. On one of my visits here, it was raining, and that produced a waterfall which terminated on the beach. Here is an example of some of the fossils exposed on the beach at this southern location of the Purisima Formation. These fossil shells are mostly the bivalve Anodara trilineata, which went extinct about 2 million years ago. Kimberto, thanks you for watching the Purisima Formation.